Good morning, students. In the previous video session, you have gone through the work done by a constant force and the work done by a variable force. Then you have seen that the kinetic energy and the potential energy. Let us discuss a new topic, work kinetic energy theorem. This is one of the very important question, 5-mark question in this unit, and it is a very simple question. So from 4th unit, this is one of the very important question as well as very simple question. So the thing is, we know that work and energy are equivalent. So work and energy is equal means surely the work and kinetic energy also will be equal. For that only we are proving that work and kinetic energy is equal. Already it is proved the work and energy is same, and we know that we have learned many example also, but here it is trying to prove that work and kinetic energy also equal. So for that we are considering a body which has a mass m. Assume that this is a body and which has a mass m, and this one is kept on a horizontal frictionless smooth surface. Now a small constant force is applying on this object so that there will be a displacement. So some work is done. That work done is equal to W equal to Fs. W equal to work done is equal to force into displacement. This is equation. And the next thing is, you see this force. What is this force? How much this force? That is what? For that we are taking Newton's second law. So Newton's second law, we all know that F is equal to ma. All of you listen very carefully. Very simple question only. So first we are taking W equal to F into S, force into displacement, work done formula. Then we are taking Newton's second law, F is equal to ma. Then we are taking this formula, V square is equal to U square plus 2as. Equation of motion, third formula. From this we need to find out this a. So V square, take this U square this side, it will come minus U square equal to 2as. So 2as is equal to V square minus U square. The same thing only I wrote here. Then from this find out a. So a is equal to V square minus U square divided by this 2 and s will come here. So 2s. This is equation 3. Now just a substitution. You see what I am going to do. Substitute equation 3 in equation 2. This is equation 2. So equation 2 is F is equal to ma. Instead of a, you have to put this V square minus, so m into V square minus U square by 2s. So substituted. So equation 3 is substituted in equation 2, so that you will get this one. Now put it in bracket. This is equation 4. Another substitution. Substitute equation 4 in equation 1. In this equation, instead of this F, you have to substitute this equation. So W equal to, instead of this F, substitute this m V square minus U square by 2s. into S. Substituted. Now W equal to multiply this M inside. So M V square minus M into U square. So M U square divided by 2S into S. Now multiply this S inside. So W equal to M V square into S minus M U square into S. I am splitting this into 2. So divided by 2S. Here also divided by 2S. Here minus will come. This minus I am cancelling. So splitted. Multiplying this S inside and this is splitting into 2. That much only. Next step, S cancel. Here S cancel. So we will get W equal to MV square by 2 minus MU square by 2. So we can write this W equal to 1 by 2 MV square minus 1 by 2 MU square. So here the same equation only. I am taking this 2 outside. So 1 by 2 MV square. Here 2 I am taking here 1 by 2 MU square. So what is this MV square? We know that kinetic energy is equal to half MV square. Kinetic energy is equal to what? Half MV square. So W equal to, we can write this equation. This is what? Final kinetic energy. This is initial kinetic energy. So change in kinetic energy from initial to final, kinetic energy is changing. So delta K E you can use. This is what work energy theorem. Very simple and very important 5 mark. So just go through this. First we have to take work done formula. W equal to Fs. Then F is equal to Ma you have to take. Then what? We have to take equation of motion. V square is equal to U square plus 2As. From this we need to find out A. So A is equal to V square minus U square by 2S we will get. Now substitute this A value in equation 2. So F is equal to M into V square minus U square by 2S. Next you have to take this as equation 4. Substitute this equation 4 in equation 1 instead of this F. So W equal to M into V square minus U square by 2S into S. Now multiplying this M inside. So MV square MU square by 2S into S. Then again multiply this S inside. So MV square into S divided by 2S minus MU square into S divided by 2S. S cancel. So that MV square by 2 minus MU square by 2. And I am writing this equation 1 by 2 MV square minus 1 by 2 MU square. And what is this? Half MV square means it is kinetic energy. Here from minus final to initial to final. So that I am writing change in kinetic energy. That is what on 5 mark question. And here some cases are there. You can see some of the application. You see this 3 point also you have to write. If the work done by the force on the body is positive, if work done is positive, kinetic energy increase. If work done is negative, kinetic energy decrease. If no work done, no change in kinetic energy. This 3 point also you have to write along with this question. So first point is, if the work done is positive, kinetic energy increase. Work done negative, kinetic energy decrease. no work done, no change in kinetic energy. This 3 point you can write along with this. And this is in the page number 174, work kinetic energy theorem, up to here 174 and 75. So it is very important question, study that. Next one is relation between momentum and kinetic energy. This is also another important 3-mark question. So important 3-mark. So this is another important 3-mark question, relation between momentum and kinetic energy. So for that we are considering again on mass m, and assume that it is moving with a velocity v. So when it is moving with velocity v, it has some linear momentum p is equal to mv, linear momentum. And we know that its kinetic energy is equal to half mv square. So we are finding the relation between this momentum and the kinetic energy. For that I am taking equation kinetic energy is equal to half mv square. Next step, I am splitting this v so that I can write ke is equal to half mv into v. This v square I am writing v into v. Vector symbol you put, important. Now this is equation 1 you can take. Now from this what you can do means multiply and divide m in equation 1. Multiply and divided by m in equation 1. So with this equation you have to multiply by m and divided by m, so that kinetic energy is equal to half m multiplied by m divided by m, v into v. Now you see kinetic energy is equal to this m and v I am writing separately, 1m and 1v. 1m and 1v I am writing separately. So mv. Again this m and this v I am writing separately, mv divided by m. What is this mv? mv means p, linear momentum. So p is mv. So I can write the kinetic energy is equal to half here p into p by m. So what will come? Kinetic energy is equal to half p square by m. I can write this equation, kinetic energy is equal to p square by 2m. So this is equation 2. Also you can write the same equation you can write from equation 2 I can write in terms of p square by 2m is equal to kinetic energy, p square is equal to 2m kinetic energy. So p is equal to root of 2m kinetic energy. Okay, so both method up to here you have to write. So this is another important 3-mark question. You can take a screenshot of this and study. This is also okay. So again listen here. We are finding the relation between the momentum and the kinetic energy. For that we are taking momentum equation, p is equal to mv. kinetic energy equation. Kinetic energy is equal to half mv square. Then from this kinetic energy equation, I am splitting this v into 2, so that you see, next step I am writing multiplying and dividing m with this. So next step, half this m multiplied by m divided by m, v into v. Kinetic energy is equal to half this m, this v, this m, this v divided by m. So P is equal to mv. So mv means we are substituting P. So P into P is P square by m. So this same equation only I am writing P square by 2m. So from this equation 2, I am writing in terms of P. So P square by 2m is equal to Ke. I am taking this 2m here. Next step, P is equal to 2m Ke. So my dear students, all of you go through this video, and today I have taken one 5 mark question and one 3 mark question. Both the questions are very important, and you can see this page number 174, work kinetic energy theorem. So this is a book back question. You can see question number, long answer question number 2. State and explain work energy principle. Mention any 3 examples for it. So you have to write from here to here. First you have to write some concept. Actually this work and energy are equivalent. Here we are proving this work and kinetic energy also equal. For that we are considering one object which has mass m, and I can write some work is done by the constant force for the displacement. Then you can use the equation up to here. You can write then another next question is relation between momentum and kinetic energy in the same page number 175. Actually it is not a book back question, it is a book inside question, but it is very important question, very important 3 mark question. Previously some exam they asked this question. So all of you go through this, watch the video. This 2 question, this 5 mark question and this 3 mark question, both question you have to write this week assignment. So already yesterday I gave one assignment for you. Yesterday's assignment is work done by a constant force and work done by a variable force, and today this is your assignment, this 5 mark question, work energy principle and relation between momentum and kinetic energy. So work energy principle, you start from here and write up to here. Then relation between momentum and kinetic energy, start from here. Then write this paragraph. Then derive the expressions. Then you can write up to here. Here also you write this point. Then derivation. That is enough. Then you write this 3 point. Okay, so all of you follow the instruction properly, and this week submit your assignment. So thank you all.